Hello friends, welcome to this video, and this video is a part of a YouTube series Data Science and Machine Learning. Those who are interested in becoming a data scientist, or those who are already an expert in a data science and want to extend their knowledge, this is the YouTube series for them. Friends, in the last video we have seen how we had a by class classifier, and then we use that by class classifier to to make a multi-class classifier. So here by class classifier means the classifier can separate the two classes, or or classifier can identify the data point to fall in one of the two classes. And multi-class classifier means more than two classes will be there, and classifier will able to classify the data point in one of the multiple classes. Could be 3, 4, 10, 100, thousands classes also. Okay, so that's a multi-class classifier. So in a last video we have seen that how we implemented the multi-class classifier from the by class classifier, right? And we used I mean there are actually the two methods, one versus one and one versus all. And in the last video we have implemented the one versus one, that means OVO, we have already seen. And let me draw it again. Let me run it again. Okay, so this is true, so let me just do the false. That means it won't take time, or let it be true, no problem. Okay, so I think if I run this, I just now run the same program, and you can see these are the four classes we had. And then there were, you know, all the 20 points we tested, and for 20 points we got 100% results. Okay, this was for the four classes. That means these classes here, the class 1, class 2, class 3 and class 4. And this was a OVO training. So now what we are going to do is to see one versus all. Okay, so one versus all, what we did, we extended the same program, because all the data generations and then training the classifiers and testing data and then testing is very much similar in a one versus all also. Okay, what is the difference is that you know, it is over uh, designating the classifier. So only for this loop, so that's why we have made a OVA or OVA. So if it is a OVO, I think it will work like a this program, the data classifier underscore multiclass 01. And this is what is now right now we have in the data classifier underscore multiclass 02 version. So in this the most of the program is same as what was given in this program. Now here we have just added the if else, and this part is the same as the previous version, and only we added this. So now OVA. So what's the difference out here? See, the same kind of the designation will be there. Now here what was happening, only one CF was coming. Okay, but here the for loop and then opposite CF, that means opposite class of the classifier was getting appended, and then that opposite will come here. So what will happen, the CF, let's say this is the OVA, and let me make it false. Okay, because data is same as it was generated earlier, only these classes. So let me put here, run this. Okay, so it has Okay, so it has come here. Now for CF, range number of classes, and we have put a opposite CF. Okay, so for each of because here we have already seen that it is going to be a very simple. Actually it will just run for the ones, first class, second, third class, fourth class. Okay, and for one it will be just remaining will be there. So the for loop is to be run for this only, and then the opposite CF will nothing but the other than one class, other than two class. Here opposite CF will have a classes other than 3. Okay, so same case here, the if the CF is considered, that means this one. Okay, this subclassifier designating with the first A side class is suppose 1 or 0, then 1 2 3 will should come in the opposite CF. So that how that can be achieved, if the CF is come, so the CF will be 0. Okay, and now opposite CF we will put a 1 2 3. So we are running the another loop where VCF is equal to CF, then it will not append here, other than CF is equal to VCF will get that VCF will get appended here, and you can see okay, so the 0 0 it was not appended, now it is a 1, VCF is a 1, so it got appended. VCF is 2, it got appended. VCF is 3, it will got appended. Okay, and now you can see what is the OPPCF here, 1 2 3. Okay, and what is the CF? CF is a 0, so 0 versus 1 2 3, and that's what will come here, right? So let's go here and so sub CF has got a one entry of the classifier, which is this one, the 0 and 1 2 3. The next will be 1 will come here and 0 2 3 will come here. Okay, so just let's check that. Now CF is 1, so 0 will enter. Yes, now this will not enter because VCF become 1. Okay, now VCF become 2. Yeah, it has come in a opposite CF, and then 3 will also come, and now it will jump outside and it will enter here. So now you can see sub CF's entry, the second entry is 1, is in the one side, and 0 2 3. Okay, and actually this was the reason that we had put this second side, okay, second side of the subclassifier as a array, because multiple classes is going to come in the 1 versus all. In a 1 versus 1 it was not, but anyway we have made a generalize, and that is why now whatever was written for this, the same thing will be, same function will be used for this, and now that will consider all the content of the opposite CF. So we don't have to write anything, the same functions, same small functions will be utilized here, and it will start getting a training data for the data A here, data B here. Okay, let's see that. Okay, I think if we continue this, we got a sub classifier of 4 classifiers, right? So 0 1 2 3 1 0 2 3 2 0 1 3 3 0 1 2. Okay, so now while training, what we did, I think in the same, again the data A side will come, the A side data will come, whatever is the class in the A side, and now the B side the data will come 3 times, because the 3 classes, the remaining 3 classes data will come in the data B. So you can see this is the one got, then second, and now third also. Okay, and now it will come out, right? So now this data, you can see the data B will be very of a large number. Data B of is a 150 and data is of the 40. Okay, so because the 3 class data is there in the data underscore B. Sorry, and now that then again it is trained here, and the same thing is done there also, you know, with the positive slope of the hyperline, y-intercept of the line, and then positive first, and I think we we explored yesterday what is the use of the positive first, so need not to repeat here. So this way all this will be trained. So let's go here. Okay, so all the sub CF got trained. Where is the sub CF got trained? Okay, this is either 1 or -1 0, -1 or 1. Okay, 1 means the first side, that means the 0 has a positive values. Okay, 0 has a positive, so test point, if it is giving the positive value on the hyperline, then it will belong to this category and not to this category, like that. So if it is if it is, and suppose the line equation is solved for the test point and it is giving the negative, then this side will win, and if this side wins, then I think we give a 1 to 3 we will distribute the 1 to the 3 classes, that means 0.33, 0.33 and 0.33, right? So anything can happen, it depends on the data. We have generated a test data, same, no change as compared to the last one, and then we will get a, we continue here, and you can see again the same thing, it will give a out which one is winning, and then accordingly, you know, here see what is the out value is a 0, that means 0 side is 1, so this will get incremented, right? But if we, so if we put a here, so in some points this will win, that means out will be 1. So let's see. Okay, so now out is a 1. Okay, out is 1, that means the 0th has lost and 1 has win, 1 has won. So B side has won, so B side will have a 3 classes. So what is that? If we see the CF, what is the CF here? Yeah, this is a CF. So 0 and 2 and 3, so that will be distributed in the 0 2 3. Okay, and that is how your class score, which what is the, where is the class score? Yeah, this was a 100. Okay, now now it will become a 1, and here 0.33, 0.33, no, sorry, sorry. So it depends on the what was the classes. So 0 to 3, so 0 means this one will increment, then this will increment 2 and 3, 0 3, so it will become 1.33, 0, 0.33, 0.33. Okay, well, let's see. Okay, so it has print the score, and you can see what is this, 1.33, 0, 0.33 and 0.33 it has become, right? So that's how it will keep on calculating the score, for each of the points, because there are the 4 sub classifiers, there are the 4 by classifiers, and then it will take a decision whichever has the maximum. It is again the same same way that has been done in a 1 versus 1. So it will print the accuracy, and let's see what is the accuracy. Okay, 95%. So you can see the when we give a okay, 1 versus all, the sum got mismanaged or some got misclassified, and that is why 95%, not all the 20 samples got a right prediction. Okay, but fine, it may be you know, sometimes the randomness might give a point you know, away from the centroid. So let's see again. Okay, now 85%. Okay, now let us see again. Okay, 90%. Okay, let us see 85%. So you know, it is changing between the 85, 90, 95. But suppose the same thing if we do by a OVO. Okay, the earlier was a OVA, Now we will do the OVO, what we did in the last video. So now it will do the with the this one. Okay, so let's see what it gives. So okay, it is giving 100%. Okay, it may be by chance, so let's try it again. So you can see the superiority of the 1 versus 1 is being shown here. There are the more number of the classifiers, but the result is, this is a very ideal kind of the data, near ideal data, and still 1 versus all was not having a was giving us some misclassification, right? If I set it to A and if I run it, it is not giving 100%, but if it is a OVO, it gives always 100%. So this proves that the superiority of the 1 versus 1 over a 1 versus all, right? Okay, so now let's see, let us take a more data. Okay, so we have added some more classes here, 5, 6, right? And we are plotting here. If I put here true, right? So actually earlier the only train data was containing the class 1, class 2, class 3 and class 4. Now we will just uncomment this, so it will have a 6 classes. Okay, is there anywhere? Yeah, here also the 3 times data is generated. No, it is not a 3 times the data generated. But anyway, we can also see the only for the 4 classes also we can see. But let me just take this from here. If okay, that was a train, that was a test. Yeah, so fine, we can use the 20 classes also, or else we can go for the test samples or not. Yeah, so here we will give a what number, 4, 5, sorry, 5, and this one is a 6. Okay, and similarly if we see here, we have given a 5 and 6. Okay, because there is a 5 in a training data, 5 and 6. So similarly here we have put a same points, and now okay, -4 and -5 and 3, 4. So what was here, -4. Okay, it got changed. In fact this that got changed. So -4, 3 and 3 -6. Okay, let me take this. Yeah, so let me take this, then we will change to this also, maybe to the accommodate more classes. I think we change the centroids, because there are now 6 classes, and here we have a okay, 30 and 5 samples. Now here it is going to be 5 and it is going to be 6, and class 5, class 6 is okay, and here it got, then here it got. Okay, and let me save this. Okay, so now 4 classes. Now you want to see the data, we can show the data also, show plot data true. Okay, so let's first see the data. Yeah, so you can see the 6 classes are there, 6 classes are there. Okay, and this data was used for the training, and then in a similar vicinity we have generated the test data also, and test data now has a 30 samples, right? Because the 2 more classes has been added. So we got we got a 30 test samples and 100% results. Now what was the nature of the OVO, 1 versus 1? Okay, and maybe because now if we use a one versus all, it will give a less percentage. You can see this one, and we don't have to show it again, so we can do a false here, don't show. That means let me run this, and you can see just the 40% we got. So I think one versus one is always superior than the one versus all, right? So that's what. And you know, you can change the data, you can change the you can let me just do this. Okay, the only three classes, comment this, then here also three classes. Okay, let it get generated, but we will not add in the training and testing samples, so you don't have to make a changes here. Okay, otherwise even if you comment this, it is okay, but you are not adding it here, so classifier will not be impacted by that data even if it is generated here. And you can see here if the three classes, see now less number of classes, so 100% we are getting in a one versus all, one versus all. But as we keep on incrementing, and of course for the one versus one, it is going to come 100% only. Sorry, not 0, the 1. Okay, so it has come the 100% only. So it is, so we have seen that, you know, one versus one is performing better than the one versus all. But anyway, in this video we have seen both the sorry, in this video we have seen the performance comparison for the one versus one, and one versus all multi-class classifier if you have been given a bi-class classifier. So how to extend the bi-class classifier by using two methods, one versus one and one versus all, that we have seen in this video. So thank you for watching.